Next, we're going to look at the last part of lesson 27, which is just higher order derivatives. It's not really anything complicated. The derivative of a function is a function, so you can take the derivative of the derivative. The derivative of a derivative is called the second derivative, and that will have some meaning for us later. But right now, we're just going to go ahead and take a first derivative or second derivative or whatever it might be. So you see some different notations here for our function. A lot of times we use f of x or just y. First derivative, f prime of x with the apostrophe there, or dy over x, which we usually just say dy dx. These are just second derivative here, f double prime of x, or the second derivative of y with respect to x, so it's this, or third derivative. So we have those different notations that you will see. So let's do these couple examples here. Let y equal 3 times u to the fifth. Find the second derivative of y in terms of u at 2, at u equals 2. So first, we'll work our way through this. So we'll just do first derivative, dy dx. We can use the power rule here. This is 15u to the fourth. That's the first derivative. Well, we want the second derivative, and that's going to be the derivative of the first derivative. So this is 60u cubed. And lastly, we wanted this evaluated at 2. So I think we can squeeze this in here at the bottom. Oops, evaluated at 2 is going to be 60 times 2 cubed. Well, 2 cubed is 8. 8 times 60 is 480. So the second derivative evaluated at 2 is 480. For this next one, it's actually asking for the third derivative. I'm going to rewrite just the original function so we can easily use the power rule. So this is x to the negative 2 power. So the first derivative, negative 2, x to the negative 3. The second derivative, again, using the power rule, the negative 3 gets multiplied out front, so negative 3 times 2 is positive 6, x to the negative 4th, and then the third derivative is negative 24, x to the negative 5th. And we're going to evaluate that at 2. Now what I'm going to do here is I'm going to remember that a negative exponent means that we can put that in the denominator. So this is going to be over x to the 5th. However, we're putting a 2 in there because we're evaluating at 2. So this is negative 24. 2 to the 5th is 32. And then we can reduce, 8 goes into both of those, so our answer is negative 3 over 4. So that's the third derivative evaluated at 2.